mynews.studio.
Picture a landscape dotted with metal structures, almost like artificial plants, soaking up sunlight and cleaning radioactive soil. Can technology really speed up what usually takes nature years to handle?
Today is October 28th, 2025. Let's get started. Scientists in South Korea have developed a solar-powered artificial plant that can clean up radioactive soil, removing 95% of contaminants in just 20 days. That's far faster than the months, sometimes years, usually needed. How exactly does this device work?
The team at DGIST designed a device that mimics how real plants move water. Instead of roots and leaves, it uses engineered channels and synthetic leaves made from special adsorbent materials. Sunlight drives the whole process. Water from contaminated soil travels up through these artificial leaves, which trap radioactive cesium ions. The cleaned water then evaporates and returns to the soil. So, the soil stays moist and the cesium is left behind in the device.
So, you don't have to dig up the soil or add lots of water, and no leftover radioactive plant material, like when using real plants for cleanup?
Right. Traditional phytoremediation uses actual plants to absorb contaminants. But those plants have to be harvested and disposed of as radioactive waste. The artificial plant avoids that completely. Once the absorbent is full of cesium, you just replace it or regenerate it using an acid wash. It's more efficient and there's less waste to deal with.
Why is speed such a big deal here? Is it just about getting farmland back into use?
Speed affects safety too. After disasters like Fukushima or Chernobyl, cesium lingers in the soil for decades, which threatens food supplies and public health. The faster you can clean it up, the sooner land can be safely used again, and people can return home.
Is this ready for real-world use? Or is it still just in the lab?
Field trials are next. The researchers want to see how the device works in various climates and soil types. It's meant for disaster zones, places like Fukushima, Chernobyl, or anywhere farmland is contaminated. And because it's modular, you can scale it up or down based on how big the area is.
What about the logistics? If you have a really large contaminated area, how do you actually manage all these devices? And what if there isn't enough sunlight or the soil is unusual?
Those are real concerns. Scaling up means more planning and infrastructure. Sunlight is important for powering the system, but the modular design helps adapt to different conditions. Soil type affects how quickly water and cesium move, so performance can vary. Also, the special adsorbent materials are key, and making enough of them could be a challenge if demand rises. And of course, the spent adsorbent still needs to be handled as radioactive waste, so proper disposal is critical.
But compared to digging up tons of soil or waiting years for plants to do the job, this does feel like progress. Is there a chance the artificial plants themselves could create new contamination issues?
The closed water cycle in the device helps limit those risks. The main hazard is when you remove or regenerate the adsorbent leaves. That material has to be managed as radioactive waste. But overall, because there's less waste and it's more contained, the risk is lower than with traditional methods.
Why does this matter globally? Nuclear accidents don't happen often, but their effects last for generations.
That's really the heart of it. Cesium can persist in soil for decades, harming food safety and health. This technology isn't limited to major disasters. It can be used wherever radioactive pollution is a problem. And because it's solar-powered, it doesn't depend on other infrastructure. If it can be scaled, it could help restore farmland, accelerate recovery, and protect communities worldwide.
And it's biomimicry, taking cues from nature but making the process faster and more controlled.
That's right. It's using nature's approach, but upgraded with technology.
So, to sum up, these solar-powered artificial plants can clean radioactive soil up to 20 times faster than traditional methods, with less waste, less water, and flexible scaling. They could help places like Fukushima and Chernobyl recover more quickly, and maybe change how we think about cleaning up environmental disasters.
That wraps up today's episode. If you're interested in how technology can learn from and even outpace nature, this is a glimpse into what's possible.
Thanks for joining us. This episode was brought to you by mynews.studio. You can try it now for free.